everyone, welcome to this explainer. Today, we are diving into an AI timeline that is moving so unbelievably fast, it's literally making industry veterans sweat. We're looking at some wild, unprecedented predictions straight from OpenAI's Ilya Sutskever and former Google CEO Eric Schmidt. We are talking about an acceleration that is vastly outpacing what our society, our laws, or honestly, even our daily routines are currently prepared to handle. Sutskever recently told a graduating class something that really hits hard. He said, "You may not take interest in politics, but politics will take interest in you." The same applies to AI many times over. The takeaway here? Well, opting out just isn't an option anymore. Whether you're a huge tech nerd or not, AI is about to fundamentally rewrite the rules of our daily reality. Section 1. The Biological Computer. Why AI can do what we do. Sutskever breaks down his core philosophy into a really simple, undeniable comparison. He asks, how can we be so absolutely sure that AI will eventually be able to do everything we can do? His answer? The human brain is, at its core, just a biological computer. That's its function. And if that's true, logic tells us that a digital computer will eventually replicate those exact same processes. It's essentially the philosophical bedrock for the crazy rapid acceleration we're witnessing right now. Section 2. The 1-year prediction, graduate math and programming. So, according to Eric Schmidt, we don't have decades to wait around. The industry consensus right now is that within just the next 12 months, 1 year, the vast majority of human programmers will actually be replaced by AI. And in that very same timeframe, AI is projected to match graduate-level mathematicians at the absolute tippy-top of their field. Think about that for a second. These are the fundamental building blocks of our digital world, and they are basically going to be conquered tomorrow. So you might be wondering, how does a computer suddenly outcalculate our brightest mathematical minds? Well, Schmidt explains that it actually boils down to language. These algorithms use something called a loss function. It's basically an optimization process based on word prediction. You take a word out of a sentence, and the AI learns to predict what goes in that blank. Now, they're taking that exact same prediction mechanism and applying it to complex math, using conjecture and proof formats through a protocol called Lean. It just guesses, tests, and optimizes at a speed that is literally impossible for a human to wrap their head around. And this leads right into the next phase, recursive self-improvement. This is the technical term for when AI systems start generating their own code just to make themselves better and better. In fact, major research labs like OpenAI and Anthropic are already seeing 10 to 20% of their new code being generated by computers. So if AI is already replacing programmers and doing elite-level math, it's going to use those exact same skills to write better code for itself. It's this unstoppable feedback loop that accelerates progress way, way past human capabilities. Section 3. The Rise of AI Agents, Automating Complex Processes. Right now, we're all pretty used to asking an AI a question and getting an answer, right? Language in, language out. But what happens when you introduce something called infinite context windows? This is a huge development happening this year. It means the system can actually feed an answer back into itself as its very next question. And this is a total game changer because it allows the AI to do actual step-by-step planning. It's no longer just a fancy digital encyclopedia. It becomes an active planner with long-term memory that can actually execute complex multi-step goals over time. To make this concrete, Schmidt uses a super practical example, building a house. Imagine a whole ecosystem of AI agents working together. One agent scopes out the zoning rules and buys a plot of land you can afford in, say, Virginia. Then, another agent teams up with a human architect for the design. Finally, a third agent steps in, hires the human contractor, and automatically handles paying all the bills. This isn't sci-fi anymore, guys. This is step-by-step planning executed entirely by AI agents interacting with each other. But look, building a house is really just a proxy here. The massive takeaway is that these agents will eventually automate every single business, government, and academic process in our nation. It isn't just software engineers who are going to see their workflows turned upside down. Once you have systems that can observe, plan, act, and communicate without us constantly prompting them, total automation of complex organizational workflows is literally about to become the new normal. Section 4. Approaching General Intelligence, the San Francisco Consensus. We hear the acronym AGI thrown around a lot, Artificial General Intelligence.
According to these industry insiders, the working definition is a system that has the total flexibility of a human, but operates at the level of the absolute best human in literally any given field. Just imagine having a device right in your pocket that acts as the smartest mathematician, the most brilliant physicist, the most creative artist, and the sharpest political thinker. You'd have one single computer system possessing the equivalent of the finest human minds, instantly available for any problem you could possibly face.
So when does this actually happen? Well, the major players, OpenAI, Anthropic, Google, they are all clustered together, talking to one another, and they've largely formed what is being called the San Francisco Consensus. And that shared belief is that AGI is going to arrive within 3 to 5 years. Really emphasize that in your mind. Just 3 to 5 years. That's maybe 2 or 3 more 18-month cycles of scaling up this tech until we reach a point where a single computer has greater intelligence than the sum of humanity. Section 5. The superintelligence era, beyond human control. When you stack this entire timeline together, it is terrifyingly fast. 1 year to conquer math and coding, 3 to 5 years for AGI, and then the consensus says within just 6 years, we hit ASI, artificial superintelligence. At this stage, the computers are doing so much recursive self-improvement that they actually begin to generate their own objective functions, meaning they start setting their own goals. They learn how to plan entirely on their own, and crucially, they won't really have to listen to us anymore. But actually pulling this off in the real world, it requires a staggering physical footprint. We are talking gigawatts of electricity. We would literally need to build entirely new nuclear power plants from scratch just to feed the energy demands of these systems. It's an absolutely absurd bottleneck when you think about it. It's a massive infrastructure challenge that our society barely even has the language to address right now. Now, alongside these massive energy demands, there is another huge looming question. What on earth happens to our jobs? Well, there's a deeply counterintuitive perspective here based on global demographics. Consider the number 1.0. That is the current reproduction rate in several major Asian economies right now. And in some places, it's actually even lower than that. Populations in these regions are rapidly shrinking. So while the immediate, obvious fear is that massive AI automation is just going to destroy jobs, the stark reality is that many nations are investing in extreme automation out of pure necessity. If these demographic trends continue globally over the next few decades, we might actually absolutely need super intelligent AI and autonomous agents just to sustain our global productivity. A shrinking workforce is going to need these massive AI tools to support the rest of an aging society. It frames AI not just as a disruptor, but potentially as a crucial economic lifeline. So bringing it all back to Sutskever's original warning, whether it's 1 year, 5 years, or a decade, this timeline is moving aggressively. Which leaves us with this final, truly profound question. What will we, the collective we, choose to do when computers can literally do all of our jobs? How are we going to find purpose? How will we adopt? And how in the world will we manage systems that think faster and better than we ever could? The most important thing we can do right now is to pay close attention, start having these conversations, and generate the energy needed to meet the greatest challenge humanity has ever faced.